Okay, so get this. Imagine AI that can learn like we do, like figuring things out on its own, no hand-holding or labeled data required. That's the promise of torque clustering.
Oh yeah, it's really shaken things up.
It's this brand new algorithm, and we're diving deep into it today. Think about the potential impact, like in medicine, finance, maybe even space exploration.
It's pretty amazing.
For today's deep dive, we're looking at an excerpt from this article, Torque Clustering, a paradigm shift in autonomous AI learning. And
Yeah, it really highlights a key difference with torque clustering.
it kind of blows traditional AI out of the water, right?
Right, so much of AI now relies on supervised learning.
Like teaching a child by constantly pointing at things and naming them over and over.
Exactly, it's time consuming and can be, well, inaccurate. Humans have to label all that data for the AI to learn.
But torque clustering, it's totally different.
Yeah, it's unsupervised, meaning it learns patterns and structures in data all of its own. No human intervention needed.
So how does it do that? Some crazy complex math.
It's actually surprisingly simple but powerful. Imagine data points scattered like stars in the night sky. Torque clustering finds those mass peaks.
So those dense clusters of stars, those areas where data points are super concentrated,
Exactly, and then it analyzes the interactions between data points.
like gravity pulls objects together in space.
Precisely. And the closer those data points are, the stronger their influence on each other, leading them to cluster together.
Whoa, so it's like it's simulating gravity, but with data. That's mind-blowing.
Yeah, and this all happens without any instructions from us. Torque clustering figures out how many clusters to make and which data points belong together.
That's a total game changer. But how do we know it actually works? Like, what sets it apart from other algorithms?
Well, the article mentions torque clustering achieved a really impressive score.
Like, how do they even measure that?
It's called an Adjusted Mutual Information Score, AMI for short. It basically shows how accurately the algorithm clusters data.
Okay, so higher score means better at grouping things together.
You got it, and torque clustering achieved 97.7%.
Wow, that's incredibly high. Most other methods, they're usually stuck in the 80% range.
It's a huge difference.
So not only is it autonomous, it's super accurate too. What other advantages are there?
Well, it's also really fast and efficient.
Oh, so it can handle tons of data.
Yeah, without needing a supercomputer or anything.
Interesting.
And unlike a lot of existing methods, it doesn't need any human intervention to set parameters.
Okay, so accurate, efficient, and truly autonomous. What's this mean for us in the real world, though?
That's where it gets really exciting. The potential applications are massive, like in medicine and healthcare, finance, even space exploration.
Space exploration. Hold on, this algorithm can help us understand the universe.
It's not as far-fetched as it sounds. Think about all that data collected by telescopes and probes.
Oh, right, it's a ton.
Torque clustering could help us analyze all that data and find patterns that lead to new discoveries.
That's amazing. Let's maybe start a little closer to home, though. Healthcare. How could it change things there?
Well, imagine analyzing patient data and detecting diseases way earlier than we can now.
Early detection's key, especially for something like cancer.
Exactly. Imagine torque clustering, analyzing medical records, imaging scans, even genetic info to identify those subtle patterns that might signal a disease.
Patterns that are too subtle for a doctor to catch.
Right. It'd be like an AI detective working with doctors.
So not replacing doctors, just giving them another tool.
Exactly. Augmenting human expertise with AI.
That's pretty amazing. I see how that could be a game changer. But how about in finance?
Well, think about the stock market.
Yeah.
Torque clustering could analyze all kinds of data, historical stock prices, news, social media trends.
Wow, so it could actually predict market movements.
Potentially, yeah. It could also be a huge help with fraud detection, risk assessment, and even personalizing financial advice.
The possibilities seem endless. But before we get too carried away, are there any challenges or limitations?
That's a great question, and one we should definitely explore further. It's important to remember that torque clustering is still a new technology.
Okay, so be realistic about its capabilities.
Exactly.
All right, so we've seen that torque clustering is a really powerful algorithm with incredible potential. But it's not a magic bullet, and we need to understand how it works before we look at its applications. It analyzes data like gravity, but how does that actually translate into meaningful insights? We'll dig into those details in the next part of our deep dive, so stay tuned. Okay, so we left off talking about how torque clustering uses like a gravitational approach to analyze data.
Yeah, it's a fascinating way to think about it.
We've got all these data points scattered around, like imagine stars in space. And torque clustering finds those dense star clusters, right, the mass peaks.
Right.
But how does it figure out which stars belong in which cluster?
Think of it like this. Each data point exerts a sort of gravitational pull on its neighbors.
So the closer two data points are,
The stronger the attraction. Exactly.
okay.
And the more massive a data point is.
Meaning like the more similar it is to other points?
Right, in terms of its features, the stronger its influence.
So it's not just about like physical closeness, it's also about how much they have in common.
Yeah, torque clustering considers both distance and similarity when figuring out those gravitational interactions.
So it's like this cosmic dance, almost, where data points are swirling around, attracted to each other based on like how close they are and how much they're alike. But hold on, where does the torque part come in? Isn't torque a physics thing?
Yeah, good point. You usually think of it as like a rotational force,
Right.
but here it's more of a metaphor to describe the twisting, turning interactions between data points.
As they gravitate towards each other.
Exactly. So it's not like it's literally spinning data points,
Okay, got it.
but it uses that idea of torque to describe how they're kind of pulled and pushed into clusters.
I see. It's describing that dynamic process.
Yeah, and what you get is this ability to find those complex patterns and relationships within the data, stuff that you might miss using other methods.
So we've got this really elegant algorithm that kind of mimics the forces of the universe to like uncover these hidden structures within data.
It's pretty amazing, right?
Yeah, it's wild. But let's bring it back down to earth a little bit.
Okay.
Let's talk more about those real-world applications. Last time we touched on how torque clustering could be used in healthcare and finance.
Right.
So let's dig a bit deeper into those areas. Starting with healthcare, we talked about how its ability to detect subtle patterns could be like a game changer for diagnosing diseases, especially something like cancer.
Yeah, early detection is key.
But how would it actually work? How would it help doctors make those diagnoses earlier?
Imagine if you fed torque clustering a massive data set of patient information, like medical records, genetic profiles, imaging scans, lifestyle data, the whole 9 yards.
Okay, yeah.
It could analyze all that and identify those tiny variations that might signal the very early stages of a disease.
Variations that might be way too small for a human doctor to catch.
Exactly. It would be like having an AI assistant that can sift through mountains of data and like pinpoint the important stuff.
Those critical needles in the haystack.
Exactly.
That can be so valuable, especially for those diseases where, like, if it's not caught early enough, the treatment options are way more limited.
Yeah, that's the hope. And it's not just about diagnosis. It could even personalize treatment plans too,
Oh, wow.
based on a patient's unique genetic makeup, lifestyle factors, all that.
So it's not just treating the disease, it's treating the person.
That's the idea. It's taking personalized medicine to a whole new level.
That's incredible. And this is just one example, right?
Right. Torque clustering could also revolutionize drug discovery,
Oh, interesting.
helping researchers identify promising new drug candidates by, analyzing vast databases of molecular structures and biological data.
So instead of all that trial and error,
You could have an AI system helping to streamline the whole process.
that would save years of research and tons of money.
Potentially, yeah.
Okay, so torque clustering could make healthcare more personalized, more efficient, and just overall more effective.
That's the hope, yeah.
It's pretty amazing. But what about in finance? We talked about market prediction and fraud detection. How would that actually play out?
Well, let's say a financial institution is using torque clustering to, analyze transaction data, looking for patterns that might indicate fraud.
Right, they use algorithms now, but they're based on preset rules.
Right, and those rules can't always keep up with the way fraud is constantly changing.
They're always finding new ways.
Exactly. But torque clustering can learn and adapt on its own.
Oh, interesting.
So it can look at tons of data and find those subtle anomalies, things that might signal a new type of fraud.
Like a fraud that's never even been seen before.
Yeah, like having an AI security guard that's constantly learning, to stay one step ahead.
Wow, that's pretty cool.
And it's not just about fraud. You could use it to assess investment risk, predict market trends, personalize financial advice, all sorts of things.
So it could make the whole financial system more secure, more efficient, and more responsive to individual needs?
It has that potential, yeah.
It does. And let's not forget about its applications in space exploration.
Oh, yeah, right.
We were just about to blast off into the cosmos before we got sidetracked by all these other amazing applications.
Yeah.
So how could it actually help us unlock those mysteries of the universe?
Well, think about all the data generated by telescopes, satellites, space probes.
It's a ton of data.
Yeah, torque clustering could help sift through all that information, find those hidden gems, lead to new discoveries.
Okay, but give me some concrete examples. How could it be used in astronomy specifically?
Well, imagine analyzing images from space telescopes, looking for patterns that indicate new galaxies, star clusters, exoplanets, things like that.
Oh, wow, that's cool.
Right now, a lot of that analysis is done manually.
Which takes forever, I bet.
Yeah, but torque clustering could automate it, freeing up astronomers to focus on more, big picture things.
Makes sense.
And it could do more than just identify objects.
Oh.
It could also analyze their properties, like their size, shape, composition, movement.
So like creating an even more detailed map of the universe.
Exactly, and it could uncover hidden connections and patterns that we might not even imagine.
This is starting to sound like something straight out of Star Trek.
I know, it's pretty exciting.
But this is all real science we're talking about here.
Oh yeah, torque clustering is a real technology with the potential to revolutionize how we understand the cosmos.
So we've explored how it could impact healthcare, finance, even space exploration. It's clear that this algorithm could touch almost every aspect of our lives. But before we get too carried away with all the amazing possibilities, I think it's important to consider the other side of the coin.
Yeah, I agree.
What are the potential downsides? What are some of the challenges? We'll explore those questions in the next part of our deep dive, so stay with us. Okay, so we've spent the last two parts of our deep dive exploring this incredible potential of torque clustering, like revolutionizing healthcare, uncovering secrets of the universe.
Yeah, it's pretty mind-blowing enough.
But before we get too swept up in all the excitement, I think it's time for a little reality check.
Yeah, I agree.
No technology's perfect, right?
Right. Torque clustering has its limitations. There are some potential downsides we need to think about.
Okay, so let's talk about the elephant in the room, that AI is going to take over the world. You know, the whole robots become self-aware and decide humans are an obsolete thing.
I think it's important to separate science fiction from reality. Torque clustering is a tool. It's a powerful tool, but it's still just a tool. It doesn't have thoughts. It doesn't take actions on its own. It relies on humans for the data and to interpret the results.
Okay, so we're not in imminent danger of being ruled by some super intelligent algorithm.
Not yet, at least. But that doesn't mean we shouldn't be thinking about the potential impact of AI on society. As these technologies get more sophisticated, we need guidelines, regulations, all that to make sure they're being used responsibly.
Makes sense, like we're steering the ship, not just letting the tech take us wherever.
Right, exactly.
What are some specific concerns we should be thinking about?
One of the biggest challenges with any AI system is bias.
Oh, right.
If the data used to train the algorithm is biased, then the algorithm is going to reflect that.
So garbage in, garbage out.
Pretty much.
Okay.
Like if you have a healthcare algorithm that's trained on data that mainly comes from one demographic group, it might not be as accurate for other groups.
That's a good point. Like, we wouldn't want an algorithm that's better at diagnosing, say, certain diseases in men than in women.
Exactly. Or in white patients versus people of color, it's really important to use diverse, representative data sets when we're training these algorithms. Make sure they're fair and equitable for everybody.
So it's not enough to just focus on making AI more powerful or efficient.
Right.
We also need to prioritize fairness, ethical considerations, all of that.
Absolutely. We need to ask who benefits from this technology, who's being left out. How can we make sure AI creates a more just and equitable world?
Those are really important questions. What about the impact onto jobs? Like, if machines can do more of the tasks humans used to do.
Yeah, it's a valid concern. Some jobs will probably be automated as AI advances,
Right.
but new jobs will be created too.
So it's not necessarily robots stealing our jobs, but it's a shift in the kinds of jobs that are out there.
Yeah, exactly. And we need to start thinking now about retraining, reskilling workers for those future jobs.
It's a good reminder that technology is always changing, and we need to be ready to adapt, learn new things, and make sure the benefits of AI are shared by everyone.
I completely agree. It's crucial to have these open and honest conversations about how AI is going to impact society. We need to work together to create a future where everybody benefits.
It sounds like we're at a really critical moment.
Yeah.
AI has the potential to solve huge problems, but there are risks and challenges that we need to be proactive about.
We're definitely at a crossroads. And the path we choose will determine whether AI becomes a force for good or something that causes more inequality and division.
Okay, so what's the takeaway for our listeners? What do you want them to remember from this deep dive into torque clustering?
I think the biggest takeaway is that AI is a powerful tool, but it's not a magic solution. We have to be the ones to decide how it's developed, how it's used.
We need to be informed. We need to ask the tough questions, make sure it's being used ethically and responsibly, and that everyone shares in the benefits.
Exactly. The future of AI, it's not set in stone. We're creating it right now with every choice we make.
That's a powerful thought. And for anyone who's feeling inspired to learn more, I definitely encourage you to dive deeper into the world of torque clustering and autonomous AI.
Yeah, there's so much to explore.
Who knows? Maybe you'll be the one to develop the next breakthrough algorithm.
Thanks for joining us on this deep dive. Hopefully it's given you a lot to think about.
Until next time, keep learning, keep asking questions, and keep exploring the possibilities.